Okay, so let's solve this question. The question states that this is a function g, this is a function f, g is a function from a to b. How is that written? In function terms, like this. This is a notation that g has domain a and codomain b. I will basically define all those things, but revise you all those topics. You must have already studied them, but I will revise you all these topics because this question requires very clear concepts regarding functions. That is the whole thing about this function. There is nothing more to that, right? So this is the function g from a to b, function f from b to c, right? And their composition, that is FOG, is given is mapping from a to c, right? From a till b is the g part, and that b is fed into into f as the domain. And what is the f taking from b to c, right? So a went from a, we got till c. That is why the domain for FOG is from A to C. That is the basic information that is presented right over here. After that, F and composition FOG are onto surjective functions, right? Onto and surjective basically mean the same thing. Which one of the following is true about the function FG of G? Basically, that is the whole of the question, right? So now let me basically define the whole onto is used over here, one-to-one is used over here, injective is used here, bijective is used here, right? These notations would, if you have not revised function in a long time, because this topic basically came in 11th, right? If you not revised all those things, then you must have forgotten all of that, right? So I will give you a basic revision of them so that you can have a comprehensive understanding on what exactly the question framer wanted you to know, right? So this is a basic concept that I am trying to tell first. This is not related to this question directly, but it is used in this question, right? Suppose that there is a function f general from a to b, then a, right, this a is the domain of the function, right? And the second part, the function which the function is from a to b, right? So the part b is the codomain, right? So when you put something inside of the function, suppose f of 1, this part must lie inside of your domain, right? And by definition, every single element of the domain must have a value in the codomain. That is a basic restriction that the function has, right? So every part of domain is used, but codomain, every part of codomain need not be used, right? Suppose for instance that these are all the elements of the domain, and corresponding to every element there is an element in the range in this codomain, right? And there are some other elements also in the codomain which are not used, right? So the set of all elements which are used is known as range, right? And your codomain can be a superset of your range, right? Codomain can be bigger than your range. Simple funda, right? Once you know all that, let me get, this is the basic concept of functions, right? And now let me get to meaning of onto and one-to-one and bijective. Before I get to that, let me just tell you the nomenclature, how it is basically laid out. Onto functions are basically your surjective functions. Naming, it is just naming thing, right? Onto is basically a surjective function. One-to-one function is basically called your injective function, and both of them being simultaneously present, these are basically properties, right? These are adjective that you are basically properties that you are adding before the function part, right? This is the function part. Before that you are saying that it is an injective function, it is a surjective function, it is a bijective function, right? Bijective function, but it's both, right? So these are properties. So basically you can also call it an onto and one-to-one function, like that also, right? So basically these are properties of functions, right? Now let me get to onto functions, right? Onto function basically means that your range would equal your codomain, right? Over here, as I told you, that the basic definition of the function does not really imposes the restriction that the entirety of the codomain must be used, right? But over here, as you can see, the entirety of the codomain is used, so your range equals your codomain, right? So this is basically the property of onto function, right? This need not be the case, right? And there is then the property of one-to-one function basically means that for every single element there is a unique element in the codomain. That all property also need not be part of the function, right? For example, over here for both values 1 and 2, the corresponding value was 1, right? In this particular case scenario, your function of 1 is equals to f of 2 is equals to 1, right? This part holds, right? Can hold, cannot hold. By the definition of function, there is no restriction on that. And onto function also poses no restriction on that. But one-to-one function poses a restriction on that. That yes, two values corresponding to every single entry in the domain, the range, the corresponding elements in the range need not be the same, right? Mind you, this is just a onto function, so the entirety of the codomain is not used and 4 and 5 are not used, right? Once that part is very clear to you, I can move forward, right? This is the basic funda that you must know, right? Both of these being present, now just for analysis sake, suppose for instance that the function is both onto and one-to-one, that is, it is bijective, right? If it is a bijective function, in that situation a unique thing happens, because every single part of the codomain is used, and every single part of this, every single element of the codomain has a unique element in the domain, right? And every part of the domain is used by the definition of the function. The number of elements in your domain would equal your number of elements in your codomain, right? Because not a single element of your domain is left out, not a single element of your codomain is left out, and the mapping is one-to-one, right? And hence the number of elements have to be the same, right? So that is kind of a basic level thing that I wanted you to know. Once the basic concepts are very clear to you, now we can attack the question, right? The question states, right, that f and fog, right, are surjective functions, right? Which one of the following are the basically would have to be true, right? So let's basically draw it out, right? They are surjective, so let's just draw it out so that we can have very clear understanding on what exactly is basically happening, right? So let's do that. I'm going to do it like this. So G is from A to B, F is from B to C, right? FOG is from A to C, right? We are given that F and FOG are onto, that is surjective, right? We are given that F and FOG are onto, right? So that basically means that let this thing be C, let this thing be B, let this thing be A, right? So onto means that the range that is part of your C, right? From B there is only one mapping, right? There is one mapping, there could be repetition because it is just onto. There is not going to be any of these elements. These elements are not going to be present, right? So let's erase them. That is the only restriction that is present, because both F and FOG have, right, both F and FOG have the codomain as same, right? So the entirety of your codomain would be basically equal to your range for both F and FOG, right? So F has a mapping from B to C, right? So this part is basically very clearly understood, and FOG, right, is on to basically, what does this means? This basically means that suppose for instance your G is from A to B, right? So, and nothing is given about G right now, so let's assume that it is not neither onto, neither it is one-to-one, right? So, right, like this, if I draw it, there were some elements that I'm leaving out because it is not, G is not given as onto, right? I'm leaving it out, and from these elements the whole of this thing can be mapped. It is not really mapped in this scenario that I took, but obviously it could be mapped, right? So let's just basically change our visualization so that we can have a better understanding, right? So let's assume that the rest of the elements of B have a mapping to the same elements as the ones that are used by G, right? These two elements in and of itself must completely cover every single element of C for FOG to be onto, right? FOG to be onto is basic. FOG means what? F times G, right? Like this. So the range of G being used as a domain must cover out every single element of C. That is something that must exist for FOG to be an onto function, right? So for that to be present, this is the arrangement that is present, right? So is G over here, G, right, does it need to be onto, or it needs to be one-to-one for both of these F and FOG to be onto? Not really. As you can see very clearly in this particular scenario, it is completely evident that both F and FOG can be onto without G being either one-to-one or onto, right? This is the basic concept that I wanted to give upon you. Now once you have this concept, obviously you must do this analysis, this part, drawing this part, and then knowing the previous concepts of injective and surjective and onto and is one to one very clear in your mind, and you just basically draw this particular diagram in the examination, and seeing that yes, this kind of possibility is present, you are directly going to be able to sort out the options and get to the correct one, right? This is a MCQ type question, only one of them is going to be correct, right? The first one states that G must be an onto surjective function. No, as we have clearly seen that G neither needs to be onto, neither it needs to be one to one, right? So the first one is not really the true. Now second option gives that G must be one to one function, injective function. Not really. We have seen that this also need not be to the case, right? G must be bijective function, that is both itna. So that does not really need to be the true also, right? And what is the fourth option? The fourth option gives that G is not required to be one to one or onto function. That is basically your correct answer. Right, that is basically your correct answer. Very simple question. It was a 1 mark question, and I do hope that you must have been able to solve it by yourself. But sometimes you need validation from others to that, yeah, this is the correct way to solve it, right? And maybe you have forgotten the concept, and this video basically helped you to revise all those concepts one more time, right? And with that, if you like the video, like and subscribe, and have a very good day.